So in this short video, we try to look at the truth table for the coded convolutional encoder, and we try to see how we can obtain the truth table. First of all, what is truth table? You can be uh, given circuit with some memory, and you should be able to find how Vi1 and Vi2, where I is the subscript for time, 1 and 2 is the order of the bit, so least significant bit, most significant bit, and Ui, again I is the subscript of time and only one bit, so one bit is an input, 2 bits as the output. So rate of this code is 1 over 2. 1 is the k and 2 is the small n, so k over n is the rate of decay, code 1 over 2. Now how this Vi and V2 are related, we can see in terms of delay. If we have information U here, the information here is delayed by 1 unit, so it's UD, and the information here after this second block is delayed by 2 units, so it's UD square. So V1 is calculated by U times D plus U times D square. So if you take U common, you get 1 plus D square. Similarly here, the lower branch, it's calculated by U plus UD plus UD square. If you take UD common, then you have 1 plus D plus D square. So this is shown here that if this is U as a function of delay, this is without any delay, then this is multiplied with 1 delay, and this is multiplied with 2 delays. So all of this is just mathematical interpretation of how output is calculated based on the input. Now if you want to plot it as a truth table, then the important things which are at the input are this side of the table. So if I draw a line here, then on the left hand side of the table you have the inputs. So we have to try with all possible inputs. So state 0 0 has two possible inputs, 0 and 1. Then state 0 1 has two possible inputs, 0 and 1. So there are 4 possible states, 0 0 0 1 1 0 and 1 1, and each state I have to try with both 0 and 1 as an input U. Now for each of them I have to calculate two things, the next state and the output. Of course output will be calculated using these formulas here, right? And next state can be calculated using the information that anything which is at the input of the memory block comes at the output of the memory block when the next time cycle comes in the clock. So for example, if 1 was here and 0 was here, then and 0 was here, so current state is 0 0, but next time this 1 will come here and this 0 will go there, which was previously here, that 0 will go there, and this 1 which was previously here will come here. So the next state will be M1 will be 1, M2 will be 0. So M2 is the most significant bit, so on the left hand side, least significant bit on the right hand side. So this kind of ordering should be given or should be clearly stated when you are solving a question, that this is my assumption that 2 represents most significant bit and 1 represents least significant bit. Okay, now for these given inputs, I have to write formulas for each of these 4 outputs. Of course, formula for V2 is easy to write. It should be exclusive OR between U, between M1 and M2. So this is U, this is M1, and this is M2. So exclusive OR of all these 3 columns should give me my V2, which is this column here. So all these inputs here, they should be calculated by exclusive OR of all these 3 bits. So you can check here, 0 is exclusive OR of all 3, 1 exclusive OR of all 3, 1 exclusive OR of these 3, exclusive OR of these 3 is again 0 because 1 plus 1 is 0 by modulo 2 operation, and so on. Similarly, V1, this line here, will be calculated by exclusive OR of which 2 bits, M2, output of M2, and U. So this branch here and this column here, M2 and U. If you exclusive OR this and this, you get 0, this and this, you get 1 as shown here, this and this you get 0, this and this you get 1 as shown here, and so on. You can also write formulas for M2 and M1, which are nothing but what was at the input in the previous time frame. So M2, new output, will be same as the input of M2, which is output of M1. So M2 here, M2 at in next time slot is nothing but M2 in previous time slot, right? So you copy what you had in the previous time slot at M1. M2 in new time slot is nothing but M1 in the previous time slot. So you copy this column here, 0, 0, 1, 1, 0, 0, 1, 1 here, 0, 0, 1, 1, 0, 0, 1, 1. Similarly, the M1 in next time slot, M1 in next time slot is nothing but what U was in the previous time slot. So you copy this column here, the column of U, to create M1 in next time slot. That's how you complete this table. So that concludes this short video, and now we will have a look at how we can complete a state transition diagram using this truth table. Thanks for your attention.